Hello everyone, I'm Juliana Fajardini, and today I'll talk briefly about my project for adding Postgre support to Suricata. So I am an Outreach alum. I was an intern with OISF a bit less than a year ago. I am also a big open source sibling mentor. This is a project in Brazil to introduce underrepresented folks to free open source software. So it's sort of like Outreachy, but without the grant and focused on Brazilian folks. And while I am from Brazil, I'm currently living in Braga, Portugal. At OISF, I work as a junior developer. I also help with improving and extending our documentation, and also to be as well a commenter for the next Outreachy round. So today I'll talk briefly about my first steps with OISF, then I'll explain what was my approach for the parser, Postgre parser, then how can you help with this project because it's an ongoing project, and what are the next steps for it. So the beginning. As I said, I got in touch with OISF and Suricata as an Outreachy intern. I did not know anything about Suricata before. I am graduated in information systems, but I spent quite some time away from the tech field, and I wanted to go back, but it was really hard because I didn't have a lot of experience, and that's where Outreach Internship really helped me. At first, my project was for converting the Modbus protocol from C to Rust, but shortly after my first pull request, we found out that other community members were already working on that, and I quickly learned the importance of communication in the open source community, and that's when Jason, Victor, and Shivani came with the other idea, which is for Postgre, and it's just in Rust. It doesn't involve conversion. And how did I approach this? So there was a lot of protocol studying. Of course, there was also, and there is still, Suricata code base learning. And while I was doing that, I learned that we have the Python script set up app layer, which will generate a template application layer parser, which can help us in building a new parser, because we can have from the beginning something that works. If you want to try, you can run dot scripts, set up app layer Py, and you say if you want just Rust, or if you don't put the Rust, it will generate code for C and Rust. And you'll have a parser that is able to read. There's also a template pickup that serves as example. And I decided for that approach because as I was new to all of this world, with that I would have something that worked from the beginning. Then I decided to go with a smaller set of messages to parse, sort of like a minimum viable parser. And I wrote the non-parser for those, and alongside with the unit tests, because then we have a test-driven development somewhat. And it was also, it is important in Suricata to devise how transactions and state work in the parser, because that's how Suricata knows when to detect and when to log things. Once those were somewhat set, I proceeded to writing the logger for the e-files. And the logger is important because with that we can have Suricata verified tests, which then will help us in making sure that while we refine, refactor, and debug the code, we are not messing up with what was already built. Few more details about Postgre. It is comprised of protocols. So we have the startup phase, which is basically the connection part. Then we have simple query for SQL queries that are one-liners, so to speak. And then there are others like extended query, copy, and more complex, so to speak, ones. It is a stateful protocol, which means that the order of the messages is important. And we have one connection per flow, meaning that if a connection is dropped and we have another one, Suricata will understand that as a different flow because we will have a different port from the front end. Here we have an example of a simple query transaction as it is represented for Suricata. Most Postgre transactions for us will have at most one message from the front end, and they can have one or more responses from the back end. Here we have the simple query where there's a query, then a row description, one or several data rows, and comment complete, and ready for query, so the front end knows it can issue more commands. And as this may show to you, it can be quite verbose. Here, for instance, we have a simple query. It's a selection of all lines from the rows table, and that will render a message with field counts for each column. We will have a description. Then for each and every line of the table, in this case, we will have another message, and the lines could be also quite extensive, like I'll show in another slide. So in this version, we decided to go for not so verbose logs. We also covered the connection phase because that's important to track. We don't have all the authentication messages yet, or at least not tested, because I didn't have access to pickups with all of them. We covered the SSL handshake, which was actually the first portion that I decided to parse. Then we have the simple query that I showed, and the termination part, which is when Postgre gracefully disconnects. And again, not so verbose logs, and it's disabled by default. So if you want to test it, you have to enable it in our YAML configuration file. Here, an example of the verbose log. So that same query from before, selecting all lines from rows table. There's the description of all the columns, and then we have the results. And here we have basically just three rows, and it's already quite extensive. So we went for something where we will have access to what was the query, the command that was issued, but we will just say that the response was okay. We do not log that as of now. Another example of output is the startup message. You can have access to the user who connected to the database itself, and there are also other optional parameters which are not logged for now, but which will likely be available in a more verbose version of the logger. The fields are also filterable. So you can, for instance, search for the simple query and see what was issued. And the next steps for this is keep adding sub-protocols, as I've mentioned. We have still to add the detection functionality, update the user guide to document how the parser works, address logs verbosity and understand how the users want it to be, add more Suricata verify tests as we get more pickups, verify how this parser behaves with other databases which use the same protocol, and see what could be normalized in terms of detection keywords for, say, MySQL, and what can be reused. And how can you help? As I've mentioned a couple of times, PCAPs are an issue. So if you have, or if you could provide, especially for authentication, Kerberos v5, GSS API, SSPI, and others, that's great. Real-world use cases are also important. There are not many available trustworthy sources for that, at least I couldn't find. If you want to test it, it's on our GitHub. There's a pull request open. And if you have feedback, what should be the log fields, which you consider important, what should be the verbosity, all of that and other things is very welcome. I would like to thank you all for listening. Thanks to my mentors, Victor, Jason, Shivani. All the OISF community has been amazing so far. The outreachy organizers and community as well. If you want to reach out, here are my social media most important contacts. The blog is updated sometimes. Thanks for listening, and if you have any questions, please do so in the chat and we will address them now.